Alright guys, I wanted to get this to you so that we had something to discuss when we got back to class, whenever that might be. Bear with me, it's the first time I'm trying to do recording like this. Um, I know it's not going to be extremely interesting to you or exciting or anything like that, but it's important and it's going to be a big part of your portfolio that's the major project for this semester. The topic is domain and range, and it's something we've discussed when been given a set of points, and basically what we said before is true, that the domain is a set of all the x values, and the range is a set of all the y values. Now, to be a little bit more technical, it's really input and output values rather than x and y values, just because as you progress through mathematics and using functions in several different disciplines, you'll find that input is um, pretty often input is something like time. So they'll use t instead of x. But that's, that's neither here nor there. But just wanted to put it up there. So before, what we've talked about is a set of points. We've either been giving it in a table format like you see in this recording, or you've been giving the ordered pairs in set of parentheses and negative parentheses, negative 2, comma 3, parentheses, so on and so forth. Basically, what we said was, well, the domain is really just your x values, all right, and the range is just your y values. And if negative 1 happens twice, we really don't repeat it. So domain, negative 2, 0, 1, 3, 4, range, negative 1, 1, 3, 4. We also have seen graphs, and I talked about using like a domain meter or a range meter where you have you go across the x-axis for the domain, and every time you are going to cross over or um, your meter crosses one of the points, you beep so that you know that, oh, here's my part of my domain. So if I move across the x-axis, keep going, then beep, negative 2, part of my domain. Keep going, keep going, keep going, 0, part of my domain. Keep going, 1, part of my domain. Keep going, 3, 4, so on and so forth. Okay? So domain is along my x-axis, then my range meter going up and down along my y-axis. So if I go from the bottom, keep going, then I'm going to cross points at negative 1, keep going, at 1, keep going, 3, and at 4. So using my range meter, my domain meter across the x-axis, y. Okay, that's going to be helpful for some of us as we get into functions, which is what we're going to look at next. Okay, so functions that we've dealt with so far this year. First semester, we looked at linear functions that you looked at in algebra and geometry. Quadratic functions, same. You should have had some exposure to both those before this class. And we looked at them pretty in depth in the first semester. And then the first part of this semester, we looked at polynomial functions in general. Now, the point here, I want to make sure that we realize polynomial functions includes linear and quadratic functions. They're just certain special types of polynomial functions. We have cubic functions that are x to the third, quartic functions, so on and so forth. So linear functions are just a degree of 1, quadratic functions a degree of 2, but they're all polynomial functions. And it's going to be something you want to think about as you look at domain and range, because they're all sort of related. Okay? Now, for domain and range, they are still what we said, instead of all x values, instead of all y values. Now, it's a little bit different when we talk about functions compared to points because, well, you don't see all the x values, you see this line or this curve. And what do you do about all the points? Because there are infinite number of points in there. That's what we want to look at today. And basically, the two questions you should ask yourself are, for domain, what values can I plug into x? So you have this function, this equation, and you have an x value or x values in there. And domain is really kind of asking you, what can I plug into x? What am I allowed to plug into? Um, are there any restrictions? And we haven't really talked about too many, but there have been, like imaginary numbers. We don't want to deal with imaginary numbers. So what's going to allow me to plug in values for x, be able to solve or find values for y. Okay? And then range, what values can I get for y? So when I plug in all the values I can for x, what values am I going to get for y? And the range is a little bit more confusing um, when you're given an equation. But the graph will help us in both cases for domain and range. So we'll look at both. Okay, so then, starting off with linear functions. Y equals mx plus c, general the slope-intercept form that we usually think about lines uh, being given in that form, but they don't have to be in it. So if you think about domain, you want to think about what value can I plug into x right here. Whether it's y equals 2x plus 3, y equals x, y equals negative 3/4 x plus 7,000. Whatever function it is, what can I plug into x? What am I allowed to plug into x? What can I plug in that then I can multiply by m and then add b? All right? And essentially, we'll look at this when we see some of our examples. For any linear function, you can plug whatever number you want into any real number you can plug into x, and then you can multiply and add and get some value for y. Okay? Um, range, the range for linear functions, what values can I get for y when I plug in all values for x? So every single number, when I plug them in, what am I going to get for y? And that's kind of a little bit tough to get our minds around. Um, because how am I going to think about all the situations that are going to happen when I plug in x? And the graph will come into play here. Essentially, what the range will end up being is also all real numbers. Okay, so there's one case when it's different, and we'll look at that. So for the majority of linear functions, you'll get all real numbers for y when you plug in every single value for